So in this section, we're going to talk about some graphical representation, but for quantitative data. And you're going to notice that there's a lot of similarities and differences between uh, quantitative and qualitative data and how we could represent them graphically. So for example, frequency distribution. So if you kind of recall, in the previous section, we kind of divide the frequency distribution by categories, but since we're dealing with quantitative data, we're dealing with numbers, so we actually partition them into classes. And a little note that these classes are constructed so that each data value falls within exactly one class. So here's a little note saying that frequency distribution for quantitative data are just like those for qualitative data, but except for categories, we have classes. So let's look at an example of what a frequency distribution look like. So we have this table, this data set of 63 vehicles and how much emission they put out. So we want to do a frequency distribution for this. We have to set up some classes. So this is an example of the first class, second, third, fourth, fifth, sixth class. And you notice that each class has some sort of interval. So if your data falls within 0.0 and 0.99, you kind of count how many data are within this interval, tally them up, and then that will be your frequency. And similarly, we kind of do the same thing for each class. So for the second class, you want to see how many of your data falls within these two numbers, tally them up, and then that number will be your frequency. So it's kind of very similar to frequency distribution for qualitative data. Okay, so in each class, we have something called a lower limit, which is the smallest number of within these two intervals, and an upper limit, which is the highest number of these two intervals. So this is kind of what a frequency distribution look like for quantitative data. So let's go over some definitions. So we kind of discuss the lower class limit and the upper class limit. But the class width is the difference between the lower class limit of one class and the lower class limit of the next class. And similarly, just like we did with qualitative data, we can actually make a relative frequency, which is again the frequency over the total sum of all the frequencies. And we're going to get into this in a little bit. Okay, so using the table above, we can answer a couple questions. So what is the upper class limit of the fourth class? So we look at our little table, we count which is the fourth class. In this case is this, and we want to know what is the upper limit for this class. And remember, the upper limit is like the highest number between these two intervals. So in this case, it's 3.99. Next, we want to know the lower class limit of the second class. So again, we look at the second class, and you want to know what is the lower limit of this class, which is 1.00. So what is the class width? Well, by definition, your class width, you could say it's the lower limit for the second class minus the lower limit for the first class. So this will be 1.00 minus 0.00, which is just 1. So the class width is 1. So now let's construct a relative frequency table. And by definition, you know that this is your frequency of that class over the total number of frequency, which is 63. And this is roughly 0.143. And then for the second class, this will be 26 over 63, which is 0.413. For the third class is 0.175. And you kind of keep going with the pattern here until you go to the very end. Okay, you kind of notice that I round everything by 3 decimal places. So that's kind of like the norm for statistics, is you always, unless stated otherwise, you round to 3 decimal places. One way to check if you did this correctly is that if you add all the relative frequency, it should be equal to 1. But notice that if you actually add all the decimals, you get you get 1.001. And this 001 is because of rounding error. But since this is really, really close to 1, then this is fine. What you could do is actually just add the fractions, and that will give you 63 over 63, which is just 1. Okay, but how do we construct these classes? How do we make these? And that's what we're going to talk next. So there's a couple steps that we have to consider. So to construct these frequency table, we have to determine the class width. And there's a lot of ways to determine your class width, but in this class, we're going to talk about this little formula here. So we take the largest data value in your data set and subtract it by the smallest and divide it by the number of classes that we want. So let's say you do that and you have like a decimal. But so when that happens, you want to increase it to the next highest whole number. So here, a little example. Let's say you did this calculation and you get 7.3. Well, you just round up to 8. Notice I didn't round down. You always round up to the next highest whole number, which is 8. Then you want to create your classes. So you want to choose a lower class limit for the first class. And this number should be very convenient. It should be slightly less than your minimum data value. Remember, it's not actual your minimum data value, it's something a little bit less. So after you're done this, you compute your lower class limit for the remaining class. So your lower class limit for the second class is just the lower limit for your first class plus your class width. And you kind of keep doing that. You fill up all the other lower limits of all your other classes. Once you do that, you fill in the upper class limit. So once you created your classes, you want to tally all your data and put them in the respected classes. I know this seems a lot, but with practice, it should be really quick. Also, another thing that you should note is that when choosing your class, there's stuff that you need to know. Every data value must be into one of the classes. The class must not overlap. The class must be of equal width. And there must be no gap between the classes. All right, so let's do an example. So you take a sample of 60 people and ask them their commute distance. And the whole goal is that you want to make a frequency table using 6 classes. And that's the key thing, 6 classes. So the first step is you want to find the class width. Well, we know that the class width is that we have to find the largest data value in our data set. In this case, is 47.1. And we take the smallest data value in our data set, which is 1.1. And so our class width will be the largest data value minus the smallest data value over the number of classes that we want. And we want 6. So this gives us 7.67, which we round up to 8, the next highest whole number. So then we want to create our class. So we want to figure out our lower limit of our first class. So a little reminder that it needs to be something slightly less than the smallest data value. So 1 is a pretty good candidate. So then we want to find the lower limit of the other classes. So we know that the next one will be the lower limit of the first class plus the class width, which is 9. So a little reminder, this is just 1 plus 8. Similarly, we could do the next one will be the lower limit of the second class plus the class width. So it will be 17. So this will be 9 plus 8. And then we could do for the rest of them. So this will be 25, 33, 41. So then we want to compute our upper limit. It's just something less than the lower limit of the next class. So in this case will be 8.9. This will be 16.9 because it's the slightly less than the lower limit of the third class. So this will be 24.9, 32.9, 40.9, and lastly 48.9. Cool. So now we create our classes. So then we have to look at our data set and figure out how many of our data is within 1 and 8.9. So in this case, it will be 14. Similarly, you kind of do the same thing for the rest of the class. So it'll be 21, 11, 6, 4, 4. All right, so you don't have to tally them up just because of time, but if it helps you, you could totally can. Okay, so now that we have our frequency, we could calculate our relative frequency. So it's just the frequency of that class, which is 14, over the total sum of the frequency, which is 60. And this gives us around 0.233. Remember, I'm using 3 decimal places because that's very common in statistics. Now that you know that, you could fill out all of the other boxes. So remember from the previous section is that we were able to draw a bar graph out of these frequency and relative frequency distribution, but that was for qualitative data. So we're dealing with quantitative data, so we actually draw something different. We draw something called a histogram, which is just a graphical representation of our frequency or relative frequency distribution. So a histogram, again, is just a visual display of our frequency table, and our relative frequency histogram is just a display of our relative frequency table. But how do we make one? How do we construct a histogram? So first, we actually need to construct a frequency table, which we did in the earlier example. And then we want to label our axis with the class limits, and the vertical axis is the frequencies. Remember, we need to include a title, and of course we have to label our axis. So when we construct a rectangle for each class, the first rectangle has its left edge of the lower limit of the first class and the right edge at the lower limit of the next class. I know it seems a little bit confusing, but once we do an example, I feel like it will click. Okay, so let's construct a histogram and a relative frequency histogram from this table that we just made. Okay, so the first thing I would do is to kind of number our axis. So here on the bottom, we start from 1. Since 1 is the lower limit of our first class, and then 9, since 9 is the lower limit of the second class, and the next will be 17, 25, 33, 41. So then this will be 17, 25, 33, 41, 48. Awesome. So now we want to consider our y-axis. So since we're dealing with frequency, our numbers should be 3, 6, 9, 12, 15, all the way to 21. And notice that they're all equally spaced. I'm not jumping randomly, they're all increasing by 3. Okay, so we want to draw our bars. So how many numbers are between 1 and 9? And we look at our chart, our table is 14. So our bar is going to go all the way up to 14. Similarly, we want to know how much numbers there are between 9 and 17, which is 21. We'll go all the way to 21. And we kind of fill out all the other boxes. So this will be 11 between 17 and 25. and then 6, and then 4, 4. Great, but now we have to consider labeling our axis. So in our x-axis, we could write something like commute distance, and on the y is number of workers. Great. So let's focus on relative frequency histogram. So notice that our x-axis won't change. It will still be 1, 9, 17, 25, 33, 41, and 48. What will change is our y-axis. Since we're dealing with relative frequency, we have to increase everything by 0.05. All the way up to 0.35. Okay. Now, if you look at the table, the proportion of numbers between 1 and 9 is 0.2233, and then the proportion of number between 9 and 17 is 0.35, and you kind of go along with the table. Again, we have to label our axis, so we could write commute distance and proportion of workers, since we're working with relative frequency. Then congratulations, we just made 2 histograms. So actually, the shape of your histogram actually tells you a lot about your data. If it's have some sort of skewness, actually tells that something's impacted your data. So the shape of one's histogram is what we're going to talk about next. So shape of histograms. So your histogram is symmetric if the right half is mirroring the left half. The way I like to think about it is that if I cut my histogram in half, we'll have 2 very similar halves. Also, we know that your histogram is skewed if one side or tail is longer than the other. And let's say your histogram has a long right tail and it's skewed to the right. If it has one long left tail, it's skewed to the left. Also, the peak or the highest point is called a mode. And if your histogram is unimodal, that means it only has one mode. But if your histogram is bimodal, then it has two clearly distinct modes. So let's kind of do an example here. So you want to classify these histogram, whether they're skewed to the left, skewed to the right, or approximately normal, or approximately symmetric, sorry. So if you look at this histogram, you kind of see that if I cut it in half, we're going to have 2 very similar halves. So this is symmetric. Here, you see that one tail is longer, so you know this is skewed, but is it skewed to the left or skewed to the right? The way I like to think about it is say you have a ball in the very top of the hill, and if you push the ball a little bit, it's going down to the left. So this is skewed left. Similarly, here, we know that it has a long tail, but is it skewed to the left or skewed to the right? Again, if you want to think about it this way, if you have a ball in the very top, if you push it a little bit, it goes down this hill, so to the right. So this is skewed right. Just like a little way to think about it. If this confuses you a little bit more, don't worry about it, but this is the way I like to think about it, and it's a little bit easier. Okay, so we want to classify this histogram if it's unimodal or bimodal. So here, you kind of clearly see that there's 2 peaks here. So in this case, this is bimodal. For this histogram, there's only one big peak. So this is unimodal. And finally, this histogram, you kind of seen that maybe it's unimodal, but these 2 peaks are significantly taller than any of the other peaks. So this is bimodal. Okay, so finally we want to talk about histogram for discrete data. And the way this works is that we want to construct a frequency table in which each possible data value of the variable forms a class. Then we want to draw a histogram in which each bar represents one possible value of the variable. And to construct this histogram, usually we center our value, and then the height of the bars will be the frequency, and the bar should just be wide enough for them to touch one another. Typically, histogram for discrete data is very not common, but it is possible to create one. So let's look at this example. So let's say you're a manager at a Wendy's fast food restaurant, and you want to see how many people show up to your restaurant at every 15-minute interval. So you have this raw data. So what you do is when you create your frequency distribution, each class is the possible value of your data. So 1 all the way to 11. And then you kind of count how many people are in your, how many ones are there, how many twos are there, threes, fours, etc. So you count all those and put it in your frequency columns. So once you finish that, it's very similar to constructing a regular histogram, but you center your classes right in the middle, and your width of your bar is just large enough for each bar to touch. So you see that each class is in the middle rather than one in the left, one to the right, because there's no such thing here. But then the height is just your frequency. Don't worry about this too much. You won't really see this a lot, but it's just good enough to know. Okay, but we could also ask the question is, we could determine the distribution of the histogram, or like the shape of the histogram, and we could say like this is about symmetric.